Hi students, greeting of the day and welcome to my video channel. Now over here we are dealing with surface chemistry and this is the last topic, catalysis. There are two types of catalyst, homogeneous and heterogeneous catalyst. How these catalysts they help us, this all we'll study in detail. But the system should be known to you that this all is done so as to have a independency of the child or a student. Whenever he needs to study, he is in position to study. That application we have developed over here. So have a proper observation, and the topic is catalysis, which we are dealing right now into this video lecture.
Catalysis. Catalysis is the process in which the catalyst, that is, substance which increases or decreases the rate of reaction without participating in the overall reaction, is the catalyst, and this total phenomena where the rate of the reaction is changed is known as catalysis. Catalysis is a substance and the process in which the catalyst it converts the rate of reaction to a faster or a slower reaction. Catalyst is a substance which can change the speed of chemical reaction without itself undergoing any change in mass and chemical composition at the end of the reaction, and the phenomena is known as catalysis. If the catalyst increases the speed of reaction, it is called positive catalyst, and the phenomena is called positive catalysis. On the other hand, if the catalyst decreases the speed of reaction, it is called a negative catalyst, and the phenomena is known as negative catalysis. There are basically two types of catalysis: homogeneous catalysis and heterogeneous catalysis. As the name suggests, students, homo means same. So if the genes, that is the solute and solvent, which will be dissolved to form a process, or the catalyst and the reactant, if they are into the same phase, we say it's a homogeneous catalysis. And if the genes are different, that is hetero means different. So if they have different genes, then we say it's heterogeneous catalysis. Homogeneous catalysis, when the catalyst mixes homogeneously with the reactant and form a single phase, the catalyst is said to be homogeneous, and this kind of catalysis is known as homogeneous catalysis. If we take the example, catalytic oxidation of SO2 to SO3 in presence of NO is an example of homogeneous catalysis. Or rather, we can say in the other words, if the catalyst is present in same phase as the reactant, it is called a homogeneous catalyst, and this type of catalysis is known as heterogeneous catalysis. Now, for example, if we take decomposition, then in decomposition of ozone in presence of chlorine as catalyst, ozone combines with nascent oxygen in presence of chlorine to form twice O2. If we talk about the mechanism of homogeneous catalysis, according to the modern views or modern concept, a catalyst enters into chemical combination with one or more reactant forming an intermediate compound, which then decomposes to combine with one of the reactant to produce the product, and the catalyst is regenerated. The involvement of the catalyst in the reaction lowers the free energy of activation and hence accelerates the speed of reaction. So here there is something, the catalyst is having a new parameter or the modern view. Heterogeneous catalysis, when the catalyst forms a separate phase, usually a solid phase, it is called the heterogeneous catalysis, and the phenomena is because of heterogeneous catalyst, so it is known as heterogeneous catalysis. Example of heterogeneous catalysis is the manufacturing of sulfuric acid by contact process. Students, you may be aware of the fact that this process is known as contact process because this is only a process or the preparation in which the substance which we are preparing, we add that substance into the reactant. Means the end product is nothing but it's a reactant. We have to add sulfuric acid into the intermediate reaction so as to get sulfuric acid. So that's why it's known as contact process. In contact process, using V2O5 for the manufacturing of H2SO4 as catalyst. Usually in heterogeneous catalysis, the reactants are gases and reaction starts from the surface of the solid catalyst. This is the reason why heterogeneous catalysis is also known as surface catalysis. Or other words, we can say, if the catalyst is present in a different phase than that of reactant, is called a heterogeneous catalyst, and this type of catalysis is known as heterogeneous catalysis. If we take an example of manufacturing of ammonia by Haber's process, that is when nitrogen and hydrogen combine, both of this are in gaseous state, and iron is used as a catalyst and molybdenum as promoter. So iron is a solid. So what will happen on the basis of the theory which has been provided to us, as this heterogeneous catalysis is also known as surface catalysis, what will happen on the surface of the solid catalyst, that is iron? These gases, nitrogen and hydrogen, which are having affinity with iron, they go and get adsorbed on the surface, and when they get adsorbed on the surface, they can combine readily, and when they can combine readily, the reaction becomes faster. Now, mechanism of heterogeneous catalysis, that is also known as adsorption theory. According to the earlier adsorption theory of heterogeneous catalysis, it was believed that the reactants in gaseous states or from the solution are adsorbed on the surface of the catalyst. As a result, the concentration of the reactant molecules on the surface increases, and hence the rate of reaction increases. Further, as adsorption is always exothermic, the heat released further helps to speed up the reaction. The activity of catalyst, the catalysts have difference in their parameters, their activity, their selectivity. So when we talk about the activity of the catalyst, it is ability of a catalyst to accelerate chemical reaction. That is, if we take an example, hydrogen or oxygen in presence of platinum reacts to form water explosively. But when we talk about selectivity of the catalyst, it is ability of the catalyst to direct reaction to yield particular product, excluding the other products. It's important, students, again I repeat, selectivity of the catalyst is the ability of catalyst to direct reaction to yield a particular product, that is, excluding other products, only that product will be formed. If we talk about an example, N-heptane selectively gives toluene in presence of catalytic reaction, or rather we can say platinum is used in the combination of hydrogen and oxygen to form water in presence of platinum. So that is a difference of the parameter, and that's why hydrogen and oxygen, they are forming water. Shape selective catalysis. The catalysis which depends upon pore structure of the catalyst and the molecular size of the reactant and product molecules is called shape selective catalysis. And the best example is zeolite. These zeolites, they are obtained from the Earth's surface, they are the ores, and they are shape selective catalysts due to the honeycomb structure. ZSM5 is used to convert methanol into gasoline, and this is an important parameter. So by that method, we are in position to convert methanol to gasoline. Now, how basically that process goes? There is a simple chemical reaction. Whenever this alcohol, water is removed from it in presence of concentrated H2SO4, which was done earlier, heat is required and plenty of pressure was required. But here with this ZSM5, just that ore is kept into the tank, and at the ordinary conditions of temperature and pressure, this ethanol, it is converted to gasoline, means it's converted to alkanes. Enzymes are defined as biochemical catalyst. Chemically, all enzymes are globular proteins, which are complex nitrogenous compounds with high molecular mass ranging from 15,000 to 10 lakhs gram per mole and form colloidal solution in water. If you take an example, conversion of glucose into ethyl alcohol, which is again a part where the sugar which has been formed from the sugarcane juice and the molasses which is left, that molasses is there into this solution, that is C6H12O6. So the reaction goes as C6H12O6 in presence of zymase gives twice C2H5OH plus twice CO2. Now the characteristic of enzymes, Specificity. Each enzyme catalyzes only one chemical reaction. For example, the enzyme invertase hydrolyzes sucrose to glucose and fructose, but does not hydrolyze maltose to glucose, though both are hydrolytic reaction. Efficiency. Enzymes are very efficient catalysts. They speed up the rate of reaction by factors up to 10 to the power 20. Small quantities, only small quantity of enzymes can be highly effective. This is due to the fact that, like chemical catalysts, enzymes are also generated after their catalytic activity, but their rate of regeneration is very fast, or the order of about 1 million times per minute. Optimum temperature and pH. Enzyme catalysis or catalyzed reactions have maximum rate of physiological pH of around 7.4 and human body temperature of 37 degrees Celsius under 1 atmospheric pressure. Enzyme activators. The activity of certain enzymes is increased in the presence of certain substance called coenzymes. It has been observed that if the protein contains a small amount of vitamin as a non-protein part, its activity is enhanced. Possibly. So that is, the rate of reaction increases. Enhancements mean increase or increment into the process. Enzyme inhibitors and poisons. Just as the case of catalyst, the activity of enzyme is slowed down in presence of certain substance. Such substances called inhibitions or poisons. Mechanism of enzyme catalysis. The most accepted mechanism of enzyme catalyzed reaction is known as lock and key mechanism. Enzymes are highly specific in their action. The specific region is called the active site on its surface. The shape of the active site of any given enzyme is like a cavity, such that only a specific substrate can fit into it in such way as one key can fit into a particular lock. That's why that is known as a key and lock mechanism. The specific binding leads to the formation of enzyme substrate complex, which accounts for a higher specificity of enzyme catalyzed reaction. So students, let us recapitulate. This was surface chemistry, and the eighth topic, that is the last topic, was catalysis. And in catalysis we have seen homogeneous and heterogeneous catalyst, and from this homogeneous and heterogeneous catalyst we have taken up the reaction and seen what are the parameters for it. So have a proper revision with this video lecture, and have a proper system so as to have a sleep, proper diet and proper workout. Take care of yourself, and bye.